Okay, so here are the notes for section 2.6 algebraic proof. Um, this is a section that's all kind of again a preparation section. We're still building over and over again. And the last two sections, 2.7 and 2.8, are finally where the book really digs into um, doing problems. I mean, just using these theorems to do problems. So, um, we've talked about point signs and planes to write paragraph proofs. Now we're going to talk about writing two-column proofs and then properties of equality to write geometric proofs. So first of all, an algebraic proof. Um, we've You've done these before, you just haven't had to go to the same extent to explain a problem like this. So algebra, we use numbers, operations, and properties to perform algebraic operations. The table on the next page, which you'll have to pause probably the video to copy it down, or if it's in your textbook, copy it out of your textbook. Um, that so you can look at these properties we have for real numbers. Okay. So first of all, addition property of equality. Okay. This should make sense. If A is equal to B and you add the same thing to both sides, you get a true statement. Okay, so I'll just on a separate sheet of paper here, kind of go over to this slide and kind of show you the example is. Works for addition, subtraction, multiplication, or division. So if I have like 5 equals 5, okay, if I add the same thing to both sides, 3 and 3, I get 8 equals 8. Same number. If I subtract the same thing from both sides, subtract 2 from both sides, I get 6 equals 6. If I take both sides and multiply by the same number, I get 18 equals 18. Okay. And then if I divide them both by the same number, I get 9 equals 9. So each time, if I do the same operation to both sides, addition, subtraction, multiplication, or division, it ends up being the same thing on both sides. So that's what these first 4 properties are. Addition, property of equality, add the same things to both sides, you're fine. Subtraction, subtract the same thing from both sides, you're fine. Multiplication, multiply both things by the same thing, you're fine. Division property is the same except for you can't divide by 0. That's the only difference. Now these next 3 properties here, these are properties we're going to use quite a bit off and on throughout the next few chapters really. The reflexive property is like reflection. That just states anything is equal to itself. Okay. The symmetric property is like a line of symmetry. For instance, let me draw a little line here. It just goes right through the middle like that. And just like symmetry, it's a mirror image. The left side, A is equal to B, maps onto the right side, B is equal to A if I were to fold them over. A is on the outside for both, B is on the inside. But what the symmetric property allows you to do is just switch the order of a statement and say it's the same. As long as it's equal, you can switch the sides of the equation. The transitive property is the one that's the weirder of the 3, but it's the one we're going to use the most for the next few sections. And basically here's how it works. You have 3 quantities, A, B, and C. If A is equal to B and B is equal to C, by the transitive property, what we can just do is we can just scrub out B. We can just mark it out and say, you know what? You're not necessary. I'm going to tie A right to C. Okay. So the transitive property is if 2 things are equal to the same thing, A is equal to B and C is equal to B, then A is equal to C. And again, that's going to be something to note. If 2 things, A and C in this case, are equal to the same thing, they're equal to each other. The last property, the substitution property of equality, basically you've used this whenever you're like plugging numbers in for x. If A is equal to B, you can replace A with B and it's fine. And then the last property is the distributive property, which you know from Algebra 1, where you can just distribute A to B and A to C. Okay. Now, how do we use these? Well, we're going to solve an equation and we're going to work this all out and I'll show you the steps to do it. Okay. So what we're going to use is something called the 2-column proof. So what the 2-column proof does is instead of you writing out like a paragraph where you have all that work to do, what you do is you put all like your work here and this is all your reasons why you can do it. So we call this the statement side and this is the reasons side. Okay. So the first thing we do is we've got our given right here. So we write that down. So 2 times 5 minus 3a minus 4 times the quantity a plus 7 equals 92, and that's given. Okay, that's step 1. And a lot of times we number it. Now the next thing is we just go to solve. And the first thing I would do to solve this problem is I would distribute the 2 and the negative 4 to the respective quantities. So step 2, you get 10 minus 6a, and the negative 4a minus 28 equals 92, and that is by the distributive property. Okay. Then the next step, we combine like terms. So negative 6a and negative 4a is negative 10a, 10 and negative 28 is negative 18, 92, and you can just say like terms. Now, step 4, we add 18 to both sides, and you get negative 10a equals 110. That's by the addition property, because I added that to both sides. Then next, I'll divide by negative 10. So I get a equals negative 11, and that was by the division property. Okay. There we go. So we just solved an equation, and on the right-hand side, we wrote on every reason we solved the equation the way we did. And that's how two-column proofs work. You put all your work on the left side, you put all your explanation on the right side. Okay. Now, we can use these properties not only for algebra, like we did, we can also use them for geometry. So, reflexive property. We can say two segments have the same length, or two angles have the same measure. I'm sorry, strike that. I was misspeaking. Reflexive property states that something is equal to itself, not the two things. We only have one thing. AB has the same length as AB, which should make sense. The segment's the same length as itself. Same thing for an angle. Symmetric, if we have AB equal to CD, we can swap the order and say, okay, CD is equal to AB instead. Same thing, if measure of angle 1 equals measure of angle 2, we can say measure of angle 2 equals measure of angle 1. Okay. And then transitive, if AB has the same length as CD, and CD has the same length as EF, I can just drop out CD. Just say, you know what, CD, go, get out of the way, you're done, we don't need you. And just tie AB to EF. I don't write very well with a mouse, so I apologize. Same thing for the angles. If measure of angle 1 equals measure of angle 2, and measure of angle 2 equals measure of angle 3, cut out measure of angle 2, get rid of it, and now measure of angle 1 is equal to measure of angle 3 because these two things are equal to the same thing. Okay. So that's transitive property. And again, we'll use transitive a ton in the next couple sections and in chapter 3. Last thing before we get to the homework is the definition of congruent. This is a picky thing that every math textbook does in high school. Is it makes you put things like the right form. It's like the right language almost. And it's a translator between saying lengths are equal or they're congruent. So for example, something we're going to see quite a bit, and we'll talk about this as we in class, is you'll see something like a statement like this. In the given, you've got that two angles are congruent. These angles are congruent, these angles are congruent. But when I work with them to talk about like solving for x and plugging numbers in or something, what we have to do is replace congruence with measure. Okay. And I'll explain more of that in class. But how I go from saying things are congruent to saying their measures are equal is I use the definition of congruent angles. And you can just say definition of congruent. You don't have to specify angles or segments because we'll see it in the statement what you're using. But we're going to have to do this quite a bit. And it works backwards. If I have that things are equal, I can use definition of congruent to go back to congruent. So this is one of these little weird rules that really, you know, if you just keep plugging along in class and just keep, you know, asking questions and working at it, it becomes really easy to figure out when you use it and when you don't. But at first it's a bit overwhelming and a lot of people struggle with it. Now, for homework for tomorrow, okay, it's problems 1 through 4 in the book. So you're going to state which properties these are, you know, go back to these geometric proof properties here, or maybe all the way back to the opening properties here, but it's going to be one of these properties that you're going to use, and your job is to state which ones. So there we go, 1 through 4. Okay. If this doesn't make any sense or you got any crazy questions or just anything, please come in the morning if I'm free or come in after school and I'll help you out as best I can, help you make a little more sense of it before the lesson. All right, thanks. See you tomorrow.